Welcome back to the Academy studio by Vitrolife Group. I am very happy to present to you Christer Silversand. He is going to talk about the new temperature measuring device called VitroTemp by Vitrolife. Silver, thank you.
Thank you very much. I hope you can hear me. I can't hear myself, but I'm going to talk about temperature control of media in dishes during handling outside the incubator. Some people may think it's easy and straightforward to ensure a constant and accurate temperature when handling embryos outside the incubator. I do not agree, and I think there's a lot of embryologists that has the same opinion. It is a challenge to control temperature outside the incubator, and one reason for this is related to the type of temperature measurement probes that are commonly used in IVF. Some of these probes are simply not suitable to use for this type of measurement, and that has to do with specific characteristics of these probes. Very few embryologists are aware of this, including myself until quite recently, and that's concerning, and that's something I want to talk about today. I will, however, also introduce you to an alternative new method to do this, a method that measures temperature more accurately, measure temperature more consistently, and it's a method that is easier to use. Let's start with a few words about temperature. We all know that temperature is a critical variable for oocyte and embryo development. And we know that ensuring that embryos are exposed to appropriate temperatures during the whole treatment cycle is critical for successful IVF, and that includes handling outside the incubator. I will not stay too long here, but we know that small temperature changes could cause an effect on the viability. But what is important and what I want to mention is that higher temperatures are worse than low temperatures. So higher temperatures or temperatures above 37 can be associated with the loss of the development competence. So the most important is it's important to ensure that we never exceed 37. And I mention this now because that is what I'm going to talk about later on. So what are the problem with what are the challenge with the current methods? Why are they not working? And I will focus on one type of probes, a thermocouple type T, because that is by far the most commonly used probe in IVF. And that is also the worst to use, and you will soon understand why. So, this probe is, as I said, unfortunately not suitable to use. And it's not suitable to use because it contains a lot of copper. A thermocouple type T is made of two wires. One wire is 100% copper, one wire is 55% copper in an alloy together with nickel, which means the probe is more or less made of copper. Copper has a very high thermal conductivity, and it will interfere with the measurement. It will cool down the media you measure, it will cool down the probe, and it will measure incorrectly. And it will measure incorrectly quite badly. So, as I say, type T probes will in general measure inaccurately too low temperature, and I'm talking about several degrees. The effect of this is in the embryo lab, when you use a thermocouple type T, you will increase the temperature until you reach 37, but in fact you will be far above 37, and that is not good for the embryos. In addition, I also can mention to work with these sort of thermocouple probes is not very easy. It's sort of time consuming, they're tedious, they're hard to handle, and there is methods that is much easier to work with. So thermocouple type T thermometers, or these probes and the thermometers, they can look very different. They have different appearance. They may look different, but they have one thing in common. They all contain copper, high content of copper. So I was talking about an alternative way of doing this, and this is something that Vitrolife is introducing and launching on this congress. We have it here in the booth, and it's available to buy. It's called a VitroTemp. So VitroTemp is a new thermometer with a custom-made probe, specially designed to measure temperature in Vitrolife square dishes during handling outside the incubator. This is a completely new way to measure temperature in dishes. Vitrolife has used a different probe that is normally not used for this type of measurement and attach that to the bottom of the dish, and that's how it's working. The temperature measurement with VitroTemp is a completely different method. It's based on a temperature-dependent resistance in a platinum plate called PT100, which is attached to the bottom of the dish. So dish design ensures that you will exclusively measure the temperature where this platinum plate is, with far less thermal conductivity interference. Furthermore, by measuring with this, there is no handheld steps that could further interfere and cause errors and inconsistency. This makes this measurement very easy to use. I want to take this opportunity to just mention Jan Gunst, and I want to mention AC Sint-Jan Brugge in Ostend, Department of Laboratory Medicine in Bruges in Belgium, because these were the people who introduced me and Vitrolife to this way of measure. And now we turn this into a product. So if we look on this VitroTemp, due to the unique design and the features of this, you get three things that is advantages. You get accurate measurements, correct measurements, you get very stable and repeatable measurements, and you get easy measurements. And that's a huge difference, all these three. Accurate measurement might be the most important, and the accuracy measurements, you get that due to one, the accuracy and the sensitivity of the probe itself, because a PT100 has a higher accuracy, have a higher sensitivity. The low interfering thermal conductivity due to lack of copper, due to the design of the dish. And the third thing that makes it correct is that you actually measure exclusively at the bottom of the dish where the embryos are supposed to be. So it mimics a normal culture condition. So we have compared the temperature by using these two probes just to see what differences we see. So we have taken Vitrolife's 40 milliliter dish and Vitrolife square dish. Into we have built a thermocouple. We have a thermocouple tight T that we placed in a droplet, and we also have attached a PT100. This is a prototype of the VitroTemp, so it's the same principle. And now we can measure the temperature and see what the two probes gives in results. And this is what we found. I'm not comparing them. So I have a culture dish, 40 milliliter dish, drawn here. We have 100 microliter medium. We have 5 milliliter oil. We have the lid on. We have a PT100 attached to the bottom, and we're then going to insert a thermocouple type T probe. So this is what happened. The system is now set. So measuring the temperature with the PT100 probe, we have 37 degrees in the microdroplet, under the oil, under the lid. This is the setting. Now we insert a thermocouple into that, the way most clinics do it today. And then we see that temperature goes down when we measure the temperature with the PT100. Obviously, by inserting the thermocouple type T, we cool down the medium. But what is worse, we record the temperature using the method most of you are using out there, and we measure 33.9. This is a lot. So we measured 3.1 lower temperature by using a thermocouple type T. And since you measure a lower temperature in your lab, you will increase the temperature on your heated surface until you reach 37. But when you have measured 37, you will be very high in reality. And that is the problem. So the significantly lower temperature measurement of thermocouple type T depends on the combination of one, the incorrect measurement of the probe, and two, the cooling effect of the medium mediated by the thermocouple type T. So I did a lot of measurements, or we did a lot of measurements, and we measured in different dishes, different setups, different volumes. And in the column to the right, the red numbers you see, that's the lower temperature you measure with a thermocouple type T. It's constantly below what you measure with PT100. So the conclusion is that the thermocouple type T probe measures significantly too low temperature. And we're talking about several degrees here. So the question is, does that mean that thermocouple type T probes are not working, that they are bad? Or is it something else? So what we did is that we took a thermocouple type T probe, placed it in an incubator, meaning that the whole entire probe is in the incubator now. We also placed the PT100 inside the incubator, and we measured the temperature in these conditions. And now they measure exactly the same. So the probe is obviously working, but it's not working for that purpose. So the thermocouple type T now measures the same temperature as the PT100, which we didn't see before, showing us that it's the method that's causing the problem. So thermocouple type T should not be used to measure media temperature in dishes on heated surfaces. All this I showed you so far, the results, etc., we have summarized and have sent in to ESHRE this year for a publication. So it's now an abstract and it's a poster. And the poster number 240 so far is in that poster. And it's a poster by myself, Mark Larman, Hubert Joris, and Jan Gunst. The title is interesting. The title of this, a commonly used temperature probe could result in setting heated surfaces with the IVF lab too high. So this is sort of a warning poster, which is interesting and I think is an important one. The most important, this investigation highlights the importance of using the correct type of thermometer probe for this type of measurement. So I just turn things around and just give you an example. What is the clinical relevance of this? Well, the clinical relevance is that there is a risk that IVF lab works with too high temperature, for sure. And what will happen in the lab is that if you use this type, a thermocouple type T probe, and you set the temperature to 37 degrees in a 5-well dish and think now it's fine to put my embryos in. If you actually measure the temperature in a proper way, you have 39.3. If you do it with a 40 millimeter dish, set it to 37 degrees, you measure it to 40.5 degrees. And this is what we see in our lab. But I also been out visiting a lot of labs, been doing troubleshooting. Clinics are contacting us and say that I have problem with ICSI, I have problem with vitrification. Please, can you come and see what we're doing wrong? Every lab I visit have a too high temperature. These are the temperatures examples. A lot of my colleagues have been out as well. I would say almost all lab in the world working with too high temperatures, handling embryos outside the incubator. Important information. So at the end, there seems to be a need for an alternative method or an alternative way to measure these temperatures. And it's available now. The VitroTemp is a very important complement to Vitrolife square dishes and will for sure help clinics to set the heated surfaces correct to get the right temperature in the media working outside the incubator. When we developed this labware, one of the most important things we focused on was temperature. So these dishes are made in a special way where they have full contact to the heated surface. That helps the embryologist to know that independent of which dish you're using, you will always get the same temperature. You have a chance to control it. Now, with the addition of VitroTemp, you have made this unique series of dishes more unique. So it's a good combination and a good tool for you. Thank you.
Thank you very much, Silver.
Thank
Lovely
you.
talk. Any questions from the audience for Silver about temperature measurements? I guess, yes, there's a question.
Hi, my name is Martina. I'm from Slovakia. And I would like to ask you, in your opinion, what is really like a threshold of a higher temperature which could really compromise the quality of the embryo?
Yeah.
What is it? It's like 37.5, 37.3? Or
No. And first of all, I will be careful answering, but there's very little proper data on this. But based on experience, what we've seen, where we've been out and seen problems, trying to solve them, lower temperature, seeing effect, I would say a 38 or above. So that's where I think it's start to really see problem. But it's already at 38 degrees. I've seen a lot of clinics having 38, 39, 40 causing problems. So in that range I'm talking about.
Right, because we are very careful, so we don't like to see even 37.5.
Well,
So-
I would, if you would know it was specifically 37.5, I can't say, I don't think it will kill your embryos in any way. But working with this, we also know there is an inaccuracy in the whole system. So you always have to consider all the inaccuracy you have. And I would never personally set a heated stage. If I want to have 37 and...
No, I mean culture in incubators. Like
In
in incubators,
incubators.
you wouldn't have like 37.2 or more.
No, but in an incubator it's so much easier to control temperature.
I know,
Yeah. But I would say that you should avoid these high temperatures, and I would rather work at low temperatures. I would set the system to 36.5 instead, to have margins up, so I don't reach above 37.
Yeah, but we all know how difficult it is to
Yeah.
validate the temperature on XC microscope
Yeah.
when you involve objectives and the
But
different
if you have-
source of lights. And
If you have this thermometer, I promise you it will be much, much easier.
right, thank you.
Welcome.
I understood that the system is working so well with Vitrolife glassware. What about no glassware, plasticware, no for other film?
Yeah, well, this VitroTemp is exclusively if you're using Vitrolife square dishes.
Yeah.
Because Vitrolife square dishes has a direct contact with the surface. All other brands I am aware of have an airspace at the bottom of the dish. So this would not tell you the temperature in those dishes. So VitroTemp is only beneficial if you use Vitrolife square dishes for your culture.
We are interested in the case of IMSI, and we will use a glass dish
Yeah.
for this because it's necessary to
Yeah.
use it. But if not,
That wouldn't help.
yeah.
No.
Okay, thanks.
Thank you. Thank you once again, Silver.
Thank you.